Okay guys, so this is the first question of real analysis paper 2 of 2017. So this is first question. x1 is equal to 2 and xn plus 1 is equal to root of xn plus 20. Show that the sequence is convergent. So we will show that the sequence is convergent by proving that the sequence is monotonically increasing and sequence is bounded. Okay, so how will we show that the sequence is monotonically increasing? We will show this by principle of mathematical induction. Okay, so in the principle of mathematical induction we have to prove that this is true the given equation is true for p of 1, then we will assume that it is true for p of k, and then we will prove it that it is true for p of k plus 1 also. So by this way we will prove this. Okay, so how do we prove that the sequence is monotonically increasing? So since if we write x1 is equal to 2 and xn plus 1 is equal to root of 2 plus 20, so of course root of 22 is greater than 2, so this one holds for p of 1. Okay, so now we will assume that this is true for xk, so xk plus 1 will be greater than xk. Now we will have to prove that xk plus 2 is greater than xk plus 1 in order to prove it that the sequence is monotonically increasing. So just add 20 on the both side, and what we get, xk plus 20 will be what, we will add 20 on both the side, then we will get xk plus 1 plus 20 is greater than xk plus 20. So taking square root on both side, we get square root of this is greater than, so we get xk plus 2 is greater than xk plus 1. So by principle of mathematical induction we will get xn plus 1 is greater than xn, so hence sequence is monotonically increasing. Now we have to show that sequence is bounded. Again we will prove this by principle of mathematical induction. So we will assume that xn is less than 5 for every n belonging to natural number. Okay, so for n is equal to 1 we have x1 is less than 5 because x1 is 2, so p of 1 is true. Okay, so now we will assume that it is true for k belonging to natural number, so xk is less than 5, then we will prove xk plus 20 is less than 5 by this method. Okay, I have written down everything. It's just I can't explain because it is night, so please manage it. So by this way we have just proved that xn is less than 5 for every n belonging to natural number. Okay, so hence sequence is bounded above by 5 and below by 2, so xn is less than 5 and greater than 2 for every n belonging to natural number. So what is monotonic convergence theorem? It states that if a sequence is increasing and bounded above by a supremum, then the sequence will converge to the supremum. Okay, so that's where sequence xn will converge to 5, and furthermore we have to find out the limit. I did not write all the questions, so please look at it. So since xn plus 1 is equal to xn plus 20, and we know that limit x n tends to infinity xn plus 1 is equal to limit n tends to infinity xn is equal to L. So just put this into equation 2, we get L is equal to L plus 20, L square taking square root on both sides, L square plus L plus 20, and then we will factor out this and we will find out that L is equal to 5 and L is equal to minus 4. So since all our sequence is greater than 0, so L cannot be minus 4, so therefore sequence is converged to 5. Thank you. I will try to upload daily one question for each question of mathematics. I'm starting by real analysis. Thank you.